Right, so you're looking at June 2015. So you drop the answers in the chat. This one will be a bit different today because I didn't send this in on the Google Classroom. So we kind of be winging it as we go through, right? 1. Which of the following processes provide evidence of the particulate nature of matter? So you have capillarity, diffusion, filtration, osmosis. What do you guys think? Can we get my pen out? One of them there is totally out. 2 actually. Any idea? Filtration. Does filtration give you any evidence of particulate nature matter? Nope. So filtration is out. Right. And capillarity is out as well. So we're looking for diffusion and osmosis. 2 and 4. D. Yeah, that's right. Auntie Kenlin. Who's Auntie Kenlin? I was trying to do a processor elimination, but not everybody here. So I end up with 2 persons missing. So I can't do the elimination method. Kira. Oh, okay, so I knew it was either Kira or it was either Destiny. All right, no problems, Kira. All right, so I'll call you Kira, right? So I'll call you using the computer. Okay, that's all right. Cool. All right, number 2, mass number is the number of mass number. What's inside of that nucleus? Nothing has A. Yep, that's correct. Neutrons and protons. That's what we have. Mass number, you're always talking about, also called a nucleon number. Right, you're talking about what's in the nucleus, and in the nucleus are protons and neutrons. Right, that's inside the nucleus. So A is the correct answer for that. Number 3, which of the following elements has 7 electrons on the outer shell? So something that's in group 7, a halogens, or halides. Yep, that's correct as well. Chlorine. Right? So your first 20, make sure you know your first 20 elements, and you can do the electronic configurations. Once you list them out in numbers like that, that's what I used to do. Just write out all 20 going on like that and then start listing them out. Sometimes you just have the mnemonics for them. I can't remember having any. Right, so you just list them out like that. I kind of memorize how the letters would line up there. So once you do that, the number here is always easy to tell, like what's the electronic configuration. So this is like 2, 4. So this is carbon, right? And I would know that as in group 4, right? Chlorine is actually all the way down at 17. So we get the electronic configuration 287, right? You could only have a maximum of 2 on the first shell, 8 on the second, 8 on the third, and then it started to get a little bigger as they go forward. But you guys would stop like up to the 4th shell, where you just probably have like a 1 or 2 electrons there, right? So chlorine is in group 7. 4, an atom has 20 electrons. When it ionizes, has the same electronic configuration as 20 electrons. So we could write it out just like I was talking about. 20 is 2, 8, another 8, so that's how much? 18. And then another 2. Yep, that's correct, calcium. And you'll know, right, because argon is a gas, so is neon. Those 2 are noble gases. And sodium, well, we know sodium is a group 2, a group 1 metal, sorry. Yeah, this one has 2 on the outer shell. Sodium is actually 11, so it's 2, 8, 1. So that's a useful thing to do. Like how I did it is I would sit and I would write out the numbers 1 to 20, and then I'll write the symbols, normal symbols, and I'll do electronic configurations as well. And then these things just give you clues. Like if I have three numbers in my electronic configuration, that tells me that's in period 3, right? Period 3, group 1. I think we saw that in one of the questions. 5. We have Na24 and Na23. They're isotopes because they, what are isotopes? Look at it, something is different. Mass numbers are different. None of these fitted. So conduct electricity, so react vigorously, have the same relative atomic mass. Is that correct? They're not the isotopes because they have the same, it's different. So this is wrong. But they do have the same number of protons though. Look at this. It's a kind of ring or wrong question. They have the same number of protons, but they have different mass numbers. That's what makes them isotopes. Right? So a little bit of lateral thinking there. Everybody okay with that one? Drop a 1 if you're okay with that. Pay attention to this. This is a tricky question that you could use. Yeah? Just take your time with it when it's kind of looking weird like that. Sometimes they're trying to get you to think laterally. 6 sulfur and oxygen are in the same group of the periodic table because this is just what I was talking about a little while ago. Because they have what? To be in the same group, they have to have something similar. I'll help you a little bit on the outer shell. But they have to have similar. Give me an answer. On the outer shell. Yep, that's correct, Cristiano. They'll have the same number of electrons in the outer shell. Yeah? So to be in the same group, right? Like all our group 1 elements, except for hydrogen. You have lithium, you have sodium, you have potassium. All of these have 1 electron on the outer shell. 2, 1, 2, 8, 1, 2, 8, 8, 1. Yeah? So the number of electrons in the outer shell indicates that they're in the same group in a horizontal or vertical column, in our periodic table. 7 refers to the following quantities of atoms: 12 grams of carbon, 16 grams of sulfur, 23 grams of sodium, 12 grams of magnesium. Right? Which of the following pairs represents equal quantities of atoms? So here I don't know your relative atomic masses of some of these. Oh, they gave it to us here. Equal quantities of atoms. So we're thinking 1 mole of an atom would have a particular relative atomic mass, right? So how much is 1 mole? These are the relative mass numbers. This is 1 mole. So like this is not 1 mole. This is 0.5 of a mole, right? Again, magnesium. This is another 0.5 of a mole, right? Carbon, that's 1 mole. Sodium, that's 1 mole. So which of these answers would make sense? 1 and 2. 1 and 2 is 1 mole and 0.5 moles, so that doesn't make sense. 1 and 4, 1 mole and 0.5 moles. Yep, Alvin is on to 2 and 3, 0.5 and 1, that doesn't make sense either. D, 2 and 4, 0.5 and 0.5. Equal amounts of atoms. See what I did there? So I changed all of these mass to moles, because moles tells us the number of atoms, so we can think about it in terms of the number of atoms. And then I use that to equate, figure out which of them are equal. Everybody all right to that one? Drop a 1 if you are. Everyone's got it. Christian as well, Kira. Nice. Jadon. Shani, all right? Drop a 1 if you understand. Eight, an ion with a single negative charge may be converted into a neutral atom by single negative charge. So a single negative charge, that means that there is more electrons than protons. Because for it to have a neutral charge of 0, we want protons to be equal to neutrons. If protons is more than the number of electrons, then we're going to have a positive charge. And if protons is less than the electrons, you're going to have a overall negative charge. What did I say? Negative. Protons more electrons is positive. Protons less than electrons is negative. Right? So it's negative. Right now it's negative because there's more electrons than protons. That's the only way we could have a negative charge. So if you want it to be converted back to a neutral atom, we need to lose an electron. If we lose one of the electrons, because a single negative charge means just one more electron than proton. So if we lose this one electron, we'll then have equal amounts of protons and electrons, and we'll be back to a neutral atom. So not losing a neutron has nothing to do with protons, nothing with gaining electrons. You're looking at C. Yeah? Everybody right to that one? Very good, Navin. Drop a 1 if you're okay with it. Chan, you alright? Is your connection good? Alright, Chan is there, good. Kira is alright. Cristiano, nice. Jaden, you alright to that one? 9. Sodium reacts with water according to the equation. Right? The number of liters of hydrogen gas liberated when 0.1 moles of sodium react with excess water. How much is that? I'll wait to take a try that. Try that one for me. Very good, guys. 1.2. Right, so what we have here, number of liters of hydrogen gas at room temperature liberated when 0.1 mole of sodium reacts with excess water. So as it is here, 1 mole gives us, well, 2 moles gives me 1, right? So 2 to 1 is the ratio. 2 moles of sodium, right, gives me 1 mole of hydrogen. So 1 mole of sodium, if I move this across, will give me half a mole. So it's a 1 to a 0.5. So if I'm doing 0.1 moles, then it's going to be 0.5 by 0.1. Yeah? Yeah. 0.05. And they want the number of liters. Molar gas is 24 liters. So if you multiply there by 24, 1.2A. So you guys are correct. All right, good job. Well done. Very good. 10. A new element, R, shows a chemical property similar to the element sodium. What is the correct formula of a compound formed with R and sulfur? We saw this one before. So I'll give you guys a chance to respond. I'm going to click on the draw. Yeah, Sharon, you're correct. Yeah, because sulfur has a -2. right? We know sulfur is a 2 minus and sodium is a plus 1, and R shows similar chemical properties to sodium. So R is a plus 1 as well. So you're all right. Very good. C. Right? That's a table with charges at send in a group. So that's another one you want to know as well. 11. Barium is below calcium in group 2 of the periodic table. When both metals react with water, the main difference in observation would be the rate of reaction and what? Type of product, type of gas, reaction with litmus, solubility of the product. So we're looking at rate of reaction in a group as you go down a group. Right, you see you're talking about group 2 metals here. And then they just said that barium is below calcium. So you have calcium, then you have barium underneath. Both of them react with water, but there's a difference. Yep, that's correct. Which one would be more soluble, Navin? The solubility of the product changes as you go down the group. It becomes more soluble as you go down. That's correct. And why is that? Why is barium more soluble? Anybody could answer that one. Floor is open for answers. Why does solubility increase? Why is barium more soluble? What makes it more soluble? Why generally reactivity increases as you go down the group? More shells, easier it is to lose valence electrons. Yep, that's it. So as you go down the group, right, this is what's happening. Remember, you have period 1, 2, 3. Each of them is a different row in the periodic table. But as you go down each row, there's an extra shell. Yeah? What that does is in the center of this is your nucleus. The nucleus is very positive. So when there's one shell, the electrons are very close to this positive nucleus, right? So we know forces of attraction, opposites attract, right? So positive and negative will attract each other. But as you go down an extra, every time you go down and you get an extra shell, there's another set of electrons that is shielding the outer shell electrons from the nuclear attracting power in the center. So what happens is that the further they're away from the nucleus, the less of a pull the nucleus have on them. So it's easy for them to just drop off. So as you go down the group, right, these electrons, these valence electrons in the outer shell become more easily lost. So the reactivity increases down a group. Make sense? Drop a 1 if it does. Yeah? Good. Everybody all right to that? Cheyenne, Sheila, you good? Yes, Cheyenne. 12, so let's look at 12. Which two of the elements above, when combined with each other, form mainly ionic compounds? So looking at a metal and a non-metal. So use that same method I was telling you about before. Very good job, Navin. Navin has an answer. 2 and 4. This one is 2, 8, 7, 2, 8, 8. So this one has a noble gas structure. Right, this is carbon, you know, this group 4. This one is a metal. This is probably lithium. Right, 3. And then this one is definitely chlorine 17. We saw that before. So we need a metal and a non-metal. A group 1 and group 7 would work. So 2 and 3. Sorry, 1 and 3. What am I saying? 1 and 3. Yeah? B. That's correct. Very good. 13 to 14 refer to the following terms: giant ionic structure, simple molecular crystal, macromolecular structure, giant covalent structure. Match each substance below with one of the terms above, each of which may be used more than once or not at all. Calcium chloride. Oh, really? What would we classify that as? Yeah, anybody else? Calcium chloride. That's actually a giant ionic structure as a metal and a non-metal. So this gives us ionic bonding. right? And that's a giant ionic structure. Starch. What is starch? You see that do bio. Which one would that fall under? Crickets. Well, giant covalent. What's giant covalent? Give me examples of giant covalent. Yep, Jaden has it. Very good, Jaden. Starches C is a macromolecular structure. Right? Simple molecular would be like ammonium chloride, weak bonding. Yeah, yeah, diamond. Diamond would be a macromolecular structure. A giant ionic is like sodium chloride, calcium chloride, any salts. So a metal on any of the non-metals will give you a giant ionic. Simple molecular is like covalent, but not with very strong bonds, not like the giant covalent structures. Simple molecular would be like ammonium chloride. Um, that's the most common one that comes to mind. Yeah. 15, a separating funnel. When would we use a separating funnel to separate what? Water and ethanol, water and kerosene, water and solid sodium chloride. Sodium chloride is table salt, by the way, right? Kerosene and sodium chloride. Do you know kerosene? Do you know what's kerosene? Pitch oil. A long time we start pitch oil lamps. When electricity go, it's to buy pitch oil in the gas stations. I don't think gas stations is sell anymore. I don't even know where it's get anymore. B, water and kerosene. Yeah, kerosene has a kind of oily finish, kind of like diesel. I used to use it long ago in as a form of fuel for like flames and stuff like that. So water and kerosene, what would happen? The kerosene is lighter than the water, so it floats on top of it. And you just use a separating funnel and tap off the water and leave the kerosene there. And what we would use to separate water and ethanol, how would separate those two? Drop an answer in the chat pod for me. Water and ethanol, I'll give you a hint, they are very close boiling points. So we'll use when you have, yep, that's right, fractional distillation. Good job, Jaden. 16, which of the following substances, when added to pure water, significantly increases the water's conductivity? Another one we saw before. Water on its own is not very conductive, and that's because it lacks the presence of ions, and there's no electrons in water. But if you add some sodium chloride there, that's table salt, right? That's a table salt, the sea salt. Right, if we add that inside of there, that will give us some sodium ions and chlorine ions, and that would significantly increase the conductivity. So D is correct for this one. 17, a solution having a pH of 1, 7 being neutral, to the right is alkaline, to the left is acidic or acid. Right? What would something with a pH of 1 do? Yeah, this is a repeat. Very good. It reacts with zinc metal to produce hydrogen. Yeah, very good. 18. Which of the following halogens is a liquid at room temperature? Another one we saw before. You remember this one? And I was giving you the color of it. This time is yellow-brown liquid. Bromine is correct. This is a liquid at room temperature. Right, so I'll take a note of that one. A weak acid, best described as one that yields a low reading on the pH meter, low concentration of acid in aqueous solution, high concentration of hydrogen ions in solution, low concentration of hydrogen ions in aqueous solution. But when we're talking about strong and weak acids, we're really referring to the concentration of hydrogen ions. So a strong acid would have a high concentration, a weak would have a low concentration. So the correct answer for this one would be D, right? Weak. Give me an example of a weak acid. What do you call this in the kitchen? What's another name for it? Starts with V. Yep. And what was the formula of it? Right, to make sure you know. And you know what happens when it dissociates, right? When this breaks up, this is your anion, and this is a cation here. This is how it splits. It splits right here. Because it's weak because it doesn't fully ionize it. These three H's are attached to this carbon because from your organic, you remember, it will be like this. Yeah. What it actually loses is this H here. This H here is what makes it acidic. There's a weak acid because you have all these H's here and they're not liberated. Unlike with like sulfuric acid, when this breaks up, you get 2H plus and 1SO4 minus. Right? This yields a bigger concentration of H plus ions than this one. That's why this is considered a stronger acid, right? Higher concentration of H plus ions. Everybody understand the difference between the two? Just drop a 1 for me. Yeah? Everybody good? Nice. Very good. 20. Which of the following methods may be used in the preparation of barium sulfate in the laboratory? Barium sulfate. I don't think that's soluble. Where's my table? Acids, bases, and salts. Barium sulfate is insoluble, so you could use a what? Precipitation method. Yeah, because you'll be able to filter it out. What do you think? Make sense? For why that makes sense there. Yeah. So for these type of questions, when they're talking about like preparation of salts, remember that table that I sent to you guys? Which salts are soluble, which are insoluble, we use that. So depending on whether it's a soluble salt, if the salt is soluble in water, then you could use either a titration method or a direct combination. It depends. There's a little chart of flow diagram. Let me see if I can take a picture and send it to you guys. Send it to me group now. Right, just sent it there. So you can take a note of that table, right? That table would help you guide you in terms of what method to use to prepare salts. There's a couple others. Let me see. I'll give you some more examples. So come in handy. This is concise for chemistry. This is my Bible when I study. See how old is it in? But Chem, you go through this book, you're good to go. And it's concise too. That's what I like about it. It didn't go on rambling. Let's add one more photo. Right. Sent it. Nice. Right, so make sure and take a look at those. That's helpful for your salts, especially in terms of preparation. Alright. Alright. 20. We get 20, why is it sticking? Back up to 21. Which of the two following statements describe acid salts? Take a look at this for me. Drop some answers and then I'll check it. Just give me 1 sec. Alright guys, let's see what we get here. So I have C from Navin, Jaden says P as well. Two following statements describing acid salts. 2 and 3, they form normal salts when they replace hydrogen or the acid is removed, right? And 3, the anions can dissociate to give hydrogen ions. Yep. O is 1, the anions cannot dissociate to give hydrogen ions. And 4 is they are not capable of generating normal salts. Yeah, you guys are correct. C, 2 and 3. Right? This is the same topic too. Acids, bases, and salts that fall under acid salts. Let me see what I have that I could give to you guys on that. Meantime, 22, in which of the following reactions is sulfur dioxide acting as an oxidizing agent? Check out that one for me. We did that one before. B. All right, let's see. Nobody tried? So what you have to do is you need to look at the oxidation number, right? So let's look at the one on Alvin choose. We know oxygen has a oxidation state of 2 minus or minus 2, right? Sulfur here has to have a positive 4 oxidation state in order for me to have 2 oxygen. So here on this side, sulfur or sulfur dioxide here, sulfur is at plus 4, right? When we look at it on this side, this goes to 0. So for it to be plus 4, right, it meant that there was more protons than electrons. So it gained electrons to get here, right? So if it gained electrons to go here, right, this is being reduction oil rig. Sulfur dioxide is being reduced. And if it's being reduced, whatever is being reduced is the oxidizing agent, right? So you're correct. Sulfur is acting as the oxidizing agent. Everybody understand now? Drop a 1 if you do. Curious, finding out. Navin, very good. Christian, you're right. Chan, Jadon, you're okay with that one? Jadon is good. Christiana, you understand? Yes, she does. Excellent. Number 23. In which of the following compounds does hydrogen have a negative oxidation number? Which one? Usually in peroxides. D. Yep, that's correct. Because look at it. We know for certain Na is plus. So for it to be combining with that, right? NaH. Very good. Everybody get that one? 24. When an exothermic reaction occurs, energy is exo. Think exit. Endo is enter. Exit is to release to the environment. Yep, that's right. B. Exothermic. Yeah. 25. Which of the following observations is expected with the electrolysis of concentrated sodium chloride solution using graphite electrodes? So these electrodes are inactive. They're not going to participate. And then we need to take this into consideration. It's concentrated. So which electron is going to be preferentially discharged at the electrode? Let's see what they have. Chlorine is evolved at the anode. What we have going to the anode? At the anode, we're going to have anions going there. And the anions in solution is going to be the OH minus and the chlorine minus. Right? pH of the solution decreases. Nope, that's not going to happen. Right? Oxygen is evolved at the anode. Nope, that's not going to happen either. Sodium is discharged at the cathode. Nope, hydrogen is going to be, because hydrogen is higher. So what's our correct answer? Yep, that's correct. A. That's correct. Concentrated sodium chloride at the anode, you have Cl is discharged. And what is discharged at the cathode again? What we have going at the cathode? You see two things that would go there. Cations. And which is preferentially discharged? Yep, why is that? H plus is preferentially discharged to sodium because of its position in electrochemical series. It's lower than the sodium. That's why it's preferentially discharged. Yeah? Very good. 26. Solution X is added to acidified aqueous potassium iodide, which turns brown. Addition of starch to the solution results in a dark blue coloration. It is possible that solution X contains what? Why is chlorine discharged instead of OH? Because it's concentrated. They say. Good observation. OH is lower, but because it's concentrated, when it goes to that anode, there's more chlorine ions than OH. Right? They're all over. So they preferentially discharge. Yeah. Make sense? Right, let's look at this one here. Qualitative analysis. So what they're using, aqueous potassium iodide, which turns brown. Addition of starch to the solution results in a dark blue coloration. That means I have iodide being present. A reducing agent will be oxidized using electrons, and oxidizing agent would be gaining electrons. What do you guys have for this one? Should answer it, yeah. Any attempts before? What do you want me to explain? You're gonna say C? We're not sure. But solution X, if we go with a reducing agent would mean that oxidation loss is occurring, right? If it loses electrons, then it would probably supply the electrons elsewhere. But what about D, oxidizing agent? The oxidizing agent means that it is gaining electrons. Now, in potassium iodide, right, potassium is giving up electrons to iodide, right? That's how that bond is happening. So what we need is for iodide ion to go back to being this I2, right? It has 0 charge on top of here. So we need this to lose electrons. So if this needs to lose electrons, then somebody in solution X needs to be gaining electrons. And if it's gaining electrons, that would make solution X a oxidizing agent, T. Understand now? Drop a 1 if you guys understand, if you want to go over that again. One more time, sure, no problems. So I'm gonna clear the screen. So this is the key line inside of this. Addition of starch to the solution results in a dark blue coloration, right? Why this was the hint or the clue is iodide reacts with starch. Remember, those of you all doing bio, iodine react with starch. You'd know if starch is present. It's present if, when you add iodine, because you get this dark bluish blue-black coloration. That's how it tests for the presence of starch using I2, right? Now what it did is it took solution X and they added to this aqueous potassium iodide. Potassium iodide would be Ki, right? Ki is ionic compound because this is K plus and this is I minus, right? Iodine would fall inside the group 7. So for ionic bonding to happen, the metal loses an electron, the non-metal gains an electron, and that's how you have the formation of cations and anions, right? Now, going back to the clue, right? For me to get this dark blue coloration when they add starch to the solution, it means that iodide ion would have had to become ion like solid, right? Because the ion or the I2 molecule with the oxidation status 0 reacts with starch to give me this dark blue color. So what I know is happening here, in order for ion to go to I2, right? Even if I bounce it, it needs to lose these electrons. It needs to lose these electrons, right? If it loses these electrons, right, it means that somebody else is gaining it. Understand? Oxidizing agent is the ion that was reduced. Make sense? Oxidizing agent, we find that because we would look at where reduction is happening, and reduction is gain. So solution X, when it is added to this potassium iodide, it gains this electron from the I minus ion and that's how we get the I2 iodide molecule that reacts to the dark blue. So solution X is acting as an oxidizing agent. It's being reduced inside of that whole reaction. Make sense to you? Yeah or nay? Yeah? The others, you guys understand? Everybody understand? Yeah. This one is a kind of ring around to kind of test your understanding with it. Because they tie a couple different things in here. You have oxidation reduction taking place. You need to know how you could test for starch. Make sense? Yeah. So that was the first time we saw this one. I don't think we saw this before. 27. In which of the following substances will electrolysis not occur when an electrical current is passed through it? No electrical current being absorbed or conducted when it goes through. Dilute sulfuric acid, you have the presence of ions there. Molten sodium chloride, you have electrons. Yep, sodium hydroxide, you have ions. Solid sodium chloride, there's nothing free inside of there to allow electric charge to pass through. Right, so that would work. Very good. Moving on. 28. Which of the following factors will usually increase the rate of catalytic decomposition of hydrogen peroxide? What do you guys have for this one? This is rate of reaction. A, yeah, increase the temperature. Very good. We increase the temperature and things, then it would speed up the rate of reaction. There you go. Increasing the temperature. Not bad. 29. Which of the following substances is an amphoteric oxide? What's the most common example of an amphoteric oxide? I'll give you the formula. Yep, that's right, guys. Aluminum oxide. Excellent job. 30. Which of the following diagrams best illustrates the course of an exothermic reaction? Exothermic. Reactants have to be more than products. Remember I was telling you about this? So generally, for it to be exothermic, remember I was telling you there's the reaction or enthalpy change is really your products, HP minus your HR. We know that exothermic reaction, delta H is always negative, and for endothermic is positive. So for this to have a negative outcome, then the reactants must be higher than the products. So you're looking for one where the reactants is higher, right? Let me clear the screen. I'll maybe zoom down a bit so we see all four answers. Which one? D has both of them on the same level. C looks the same thing. B, the reactance is lower, right? So A, the reactance is higher. So this is the correct one. That's the easiest way, right? Because with the energy changes, it's just like enthalpy change, energy profile diagram, how many different things you need to know. Start from here. Enthalpy change, right? Change in temperature, change the heat capacity of the products minus heat capacity of the reactants. And the outcome of this is tell you whether it's endothermic or exothermic, right? If it's negative, you have exothermic, positive, endothermic. And then straight from here, you could draw your diagrams too. Because if I need a negative outcome for it to be exothermic, then obviously this is going to be bigger, right? Reactants is going to be heat capacity reactants will be larger than the heat capacity products. If I need it to be positive, then the opposite needs to happen. This needs to be bigger. Yeah, so then the products will be higher on top of here. This would be an example of an endo, and this here would be an example of an exo. Make sense? Drop a one if it does. Nice, very good. Right, 31. All members of the homologous series, they have similar what? Densities, boiling points, chemical properties, physical properties. Which one is it? Jadon, Navin, good. Guys, you want to take a shot at it? Cristiano, Kira, Cheyenne. Chemical properties is right. 32. Which of the following molecular formula represents the alcohol whose boiling point is 180 degrees? Let me make this a little bigger. Let me get right. So there is 5 blocks. So that's 10, 60, 70, 80, 90, 200. Yep. 60, 70, 80 will be here. 80 will be right there. A different color. Oh, yeah, again there. 7 carbon atoms. So which one of those they have 7 carbon atoms? Check for me. Let me know. Yeah, that's right. D. Right, 6 by 1 here. Give them 6 carbons and another one. Right, makes sense. You have one CH3. and then a whole set of 1, 2, 6 going all the way across here until they get to the OH on the opposite side. Very good. Not bad. 33. 33. Where's 33? There you go. What is this? Homologous series as the following structure belong to? COOH group. You all know this one. It's the correct answer for this one. 33. Everybody seeing? Yep, that's correct. Good job. Acids. Nice. Next one, 34. 34. The product I is what? We have ethene, and they're saying here concentrated sulfuric acid and water. What are they trying to do there? They're trying to get if we add that OH inside there, what are we gonna get? Yep, that's correct, Jadon. You get ethanol. Very good. And 35. The product polyethylene is a gas, liquid, solid, or solution. Polythene, the polythene bags. So what is it? Gas, liquid, or solid? I want to say C, solid. Yeah, okay. Polythene is that's a material that you'd use for most plastics. Right? What are some of the uses of it? You are when you look at polymers. It's the most common plastic. So you use like when you're doing your those you could add vinyl inside of there and you get polyvinyl chloride, right? Pretty much the same thing. What happens is instead of your ethene molecule, the difference between polyethene and polyvinyl chloride is instead of you having these, in making polyethene, you're going to be using this as your monomer unit, and then you're going to end up getting this as the polymer, right? It's a long chain hydrocarbon. Now I'll give you polyethene, and these are all the H's, right? Polyvinyl chloride, we swap out some of these H's for chlorine molecules. That's how we get our polyvinyl chloride. Yeah? So they're solids, that's plastic. The containers that mothers and squirrels so much about when they lose them. That's your polyethene there. Yeah? Forks, spoons, plastic plate, all of that polyethene that's responsible for making all those things. So those are solids. 36. Which of the following reactions occur between propene and bromine? What's going to happen there? Propene is a ethene, or it's a alkene, sorry, maybe a ethene. A alkene. And bromine is going to do what? That's kind of like what I just showed you there. Yep. Substitution? Nope. Substitution is for alkenes. Alkenes would look like this. Like ethane would be like this. And if we try to introduce bromine, it would replace the hydrogen. Substitution, like on a football field, right? H should come out, the R will come in. But with these guys, it breaks the bond. It breaks the bond and then gives you the haloalkene. Sorry, I wanted to put Br here. Br will come in there. So these are addition reactions. Yeah, everybody right with that one? Right? Halogenation is another word for that. The addition of halogens. Right, so alkenes undergo addition reactions with halogens. Alkenes undergo substitution reactions. Yeah. 37. Forward reaction. What is it known as? We've seen this already. Acid and alcohol to produce the ester. Give you a hint. It starts with E. Yep, that's right. Esterification. And backward. Start with H. Yep, that's right. Hydrolysis. 39. When large alkane molecules are cracked, the products are a mixture of smaller what? Alkene. What do we get? Alkane and alkene molecules. Everybody agree with that? Not too sure about that one? Why not? The correct one. You get both alkane and alkenes. And they're cracked. Just think about it. When it breaks in one point, right? In some places, somebody might keep the hydrogen, somebody not going to be able to get hydrogen to finish it. So the bond is flip and go there and it becomes a alkene. Make sense? Yeah. So D is correct for that. You get both alkenes and alkenes, smaller ones too. And you have two types of cracking, right? You have thermolytic cracking, or thermal cracking, and you have catalytic cracking. Right? So you usually find this in your petrochemical industry. That's how they would refine crude oil. You need to break up the hydrocarbon. Make sense? Look at 40. Which of the following reagents can be used for converting ethanol to ethanoic acid? Acidified something. That's my hint. You know, clue or Q. Or acidified something. If something is acidified, it means that it has H plus ions. Yep. And what is that called? Yep, very good, Chan. What do we call that? What is this? What do you call this? Yep, that's it. Dichromate. Almost had it. Yeah, dichromate. Acidified potassium dichromate. Yeah, about that. 41. Fermentation of sugars using glucose as a substrate can be represented by the equation. What do we get? Fermentation is your key here. And the last couple of questions was on organic. So what are you talking about here? What are we gonna get? How do we make alcohol? Yeah, that's right, Jadon. Angostura here. Yeah, you gotta get sugar. Long time they used to use the bagasse and thing from the sugarcane to do that. And you pass it on the main road there by Angostura. It used to smell that. It used to smell too good. Yeah. We're using fermentation in sugars. Your byproducts is always the alcohol and carbon dioxide gas. So C is correct. Very good. Well done, Shan. Good job, Marvin. 42. Glucose is converted to starch or cellulose by. Glucose is a simple molecule or monomer unit, as my hint. Only one type of monomer units undergo addition polymerization. So unsaturated monomer unit would undergo addition polymerization, and that's only so for polyalkenes. Everything else is what type of polymerization? The type of polymerization that usually results in the loss of a small molecule. In most instances, that molecule is water. So we're talking about condensation polymerization. So glucose, you're talking your amino acids doing proteins. You're talking about things like nylon, pterylene. They're all examples of your condensation type polymerization. Polyamides, polyesters, and starch is a polysaccharide. Yeah, all of these undergo condensation polymerization. 43. Which of the following features belong to metals? Solid chlorides, basic oxides, conduct electricity when molten. Solid chloride, sodium chloride. We saw calcium chloride earlier on. Form basic oxides, sodium oxide, magnesium oxide. Conduct electricity when molten. Yep, if they molten, they'll have free electrons. So what do you think the answer is? Yeah, D. Yeah. Most of the metals form basic oxides. Yeah, the sodium oxide, and when they add water, that's how you get sodium hydroxide, magnesium oxide. All the group 2 metals, calcium oxide, and they're strong reducing agents. Right? And when I say reducing agents, always think reducing agents, they lose electrons. That makes sense. Metals, they lose electrons to become positive cations. Yeah. 44. Which of the following processes produces a gas which is different from others? Respiration in animals, photosynthesis in plants, heating calcium carbonate, oxidation of carbon monoxide. Which of the following processes produces a gas which is different from the others? It's an interesting question. Respiration in animals produces what type of gas? When we respire, what type of gas do we get? Good. Photosynthesis in plants, what type of gas do we get? Good, very good. Right, because they take in the carbon dioxide, right? Well, if I heat calcium carbonate, what kind of gas do you think I'm going to get there? Calcium carbonate. Yep. And oxidation of carbon monoxide. Oxidation is loss. What we're going to get? Another CO2. So what's my answer? Yep. Very good. Well done. Everybody understand now? Drop a one if you do. Yeah, that was the first time. I didn't see that question before. 45. Which of the following metals will not displace hydrogen from dilute hydrochloric acid? Reactivity series. Something that's below hydrogen. Girl had the fancy mnemonic. Just laughing about it some time ago. Mine was people sometimes collect magazines about zoos in London having cute monkeys, cute being copper. And small gorillas. Yep, copper car displays. Having cute monkeys, H is above it. Very good. 46. Which of the following methods is used for the extraction of aluminum? Plenty energy. A lot of energy. It's the correct one for this. It is not reduced. And we have to use a molten oxide. Yep, very good, Cristiano. A, electrolysis of its molten oxide. 47. Which of the following statements about sulfur are true? This is one that we saw before. I was explaining vulcanization of rubber, extraction of iron from iron ore, use in manufacture of explosives, extraction of iron from iron ore, sulfur. Very good, Cristiano. 1 and 3. Good job. 48. Which of the following substances conducts an electric current but remains chemically unchanged? What do we use in our wiring, our homes and stuff? Yep, very good. Copper. Good. Bad at all. 49. Let's see, 49. Which of the following gases is not considered to be toxic? Any ideas? Nitrogen dioxide, yeah? Nitrogen dioxide, that's correct. Sulfur dioxide as acid rain. Carbon dioxide as a toxic gas. And carbon monoxide. Carbon monoxide, you get that from the fumes in your car, you could actually kill somebody with carbon monoxide. Right? 50. The compound which has the formula CH3CHCH blah 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 is a what? What is that? It's a presence of something. C. Carboxylic acid. A. Alkene. You have the presence of the double bond. Going back to the other one, I was just googling nitrogen dioxide. Nitrogen dioxide is actually toxic. Carbon dioxide is only harmful in large quantities, and no carbon monoxide is toxic because you can get carbon monoxide poisoning. Yep. 49. Yeah. Sulfur dioxide is mildly toxic. So out of all of them, carbon dioxide is the least harmful out of all three. 49A. Right, if you check it, I just checked all four of them. Carbon dioxide only harmful if it's like it's in very large quantities. The carbon monoxide is you could suffer from carbon monoxide poisoning. Nitrogen dioxide is also toxic. You have health effects for carbon dioxide, but low concentrations are not harmful. Higher concentrations affect respiratory function, cause excitation followed by depression of the central nervous system. So it's not toxic. Carbon dioxide is not a poisonous gas. Right, so A, not considered to be toxic or poisonous. The others are. Yeah, A for 49. Everybody okay with that? And 50 was A because we have the presence of this double bond here, unsaturated. 51. When copper 2 carbonate is heated alone in a dry test field, a gas is evolved and a black residue is formed. The gas is expected to do what? A carbonate here. So more than likely this is CO2. Red litmus glue in sprint decolorized forms white precipitate with aqueous calcium hydroxide, also known as lime water. What's the correct answer for this? What's your test for carbon dioxide gases? Yep. Bubble it through lime water. If it turns a milky white precipitate, we know that carbon dioxide is present. 52 refers to the following experiments, right? Seeing sulfuric acid, manganese oxide, sodium chloride. In which experiment would the greatest amount of chlorine be collected? This one has heat. This one doesn't have heat. And then you have these pointing downwards, these pointing upwards. So what we have here? What you guys have? Let me just scroll down so you see answers. A single answer. You want to say A. A is 1, but you have that test tube down. What about 4? You have heat there, so heat is going to speed up the reaction. If you think back to your preparation of gases, most of the time when you're preparing your gases, those are you have that gas going upwards, yeah? So D. Yeah, most of the gases would rise and because of the heat, and then they'll travel through the now you're looking for the greatest amount to be collected. In both instances they would, but you wouldn't really if you compare the two, upward and downward, not totally sure. My influence on this is the gas would rise. So if I have the test tube up, the gas already flowing up this way. So continue to flow up. Hey, you want it to go this way and then travel downwards. So yeah, I don't know. I think more would be collected this way as opposed to downwards. I'm going based on how I would usually see the setup for apparatus for gases. They'd usually collect the gases up in this upward type direction like that. Right? Or if they don't do that, they would have the syringe on the end of it going across. Right? I've never really seen a setup with the gas with the beaker down. Yeah. And even if it's down, like if they're bubbling the gas up, it would take up, like it would probably come down like this and then cut across to still bubble back up. I don't know. That's just my take on this one. You always get a second opinion and get back to you on that. 53. Which of the following observation is expected when aqueous silver nitrate is added to aqueous potassium chloride? Aqueous silver nitrate. That is a test for cations. Not cations, sorry, anions. We use silver nitrates and usually followed by ammonia. When there is the presence of chlorine, we get a white precipitate. Right, and then they tie this in. So we'll get white precipitate if chlorine is present when I use silver nitrate. We're looking for the observations. The correct answer will be C. Right. So that's a test for, that one is a test for, let's take a shot of that here. Just send you a picture in the group there to test for anions. This is a test for anions using, let's reply on this message. Nice. 54. Which metal reacts vigorously with water to produce a strong alkaline solution? We have aluminum, copper, iron, and sodium, something that's high in the reactivity series. And it gives a strong alkaline solution. I was giving an example just now when we were talking about metals forming oxides, and when it reacts with water, they get a strong hydroxide. It was a very strong hydroxide. Yep, that's correct. D, sodium. Right, sodium is very high. It's a group 1 metal, right, and forms a very alkaline solution. Yeah. 55. Which metal has an alloy which is used in the manufacture of aircrafts? Something that's light and durable. E. Very good. Sorry, E is this one. This one was D. Right. 56. A gas C has physical and chemical properties similar to ammonia. The best method for collecting a pure dry sample of Z would be, scroll down a bit. Pure dry sample of C would be to pass it through what? When we doing ammonia preparation of gases, this is one we saw before. Remember this? Anybody? We're almost finished. I'm unsure. Just send me a picture in the group. Check that out. Has to do with something with calcium oxide. Yep. B, calcium oxide collect by upward delivery. So you were saying with gases, like for that one we did just now. So ammonia, I'm sending you a picture in the group. So that's how they do ammonia, preparation of ammonia. If you take a look at it when you get a chance. Right, so B is the correct answer for that. If you look at our diagram, you'll understand how we came up with the answer. Right, that's a good one to learn as well. 57. The main substances responsible for acid rain. What's the main culprits of acid rain? Yep, D, sulfur dioxide and sulfur trioxide. That's good. 57, D. 58. Although aluminum is more reactive than iron, iron becomes corrosion resistant. Aluminum becomes corrosion resistant when left exposed to the atmosphere, while iron corrodes. This is because the aluminum does what? Anybody remembers this one? Aluminum oxide forms a film on the outside of the aluminum and protects the metal from further corrosion. Right? Iron oxide doesn't. Iron oxide actually continues or encourages the process of rusting. C. Yeah. 59. Which of the following substances is an important constituent of chlorophyll that gives it that green color? Do you know the answer for this one? Yep, very good, Jadon. D, magnesium. That's where we get all sorts of magnesium when we eat green chlorophyll looking food, bhaji and spinach and pak choy. 60. Which of the following gases will give a positive test with dry cobalt chloride paper? How do we use dry cobalt I got to tell you this last time. Yeah, water vapor. D. Right? So this was not bad, people. This one had a lot of new ones that we didn't see before. Yes, correct, Sharon. Very good. D. Right? So that wasn't too bad. We just stop the recording.